is about functions and their graph. As you know, functions have relations and relations have graphs. Therefore, functions have graphs. Okay? And what's a graph of a function? It's just a collection of all the points x, y that satisfy whatever equation the function is defined by. Okay? So, definition, let y equal f of x be a function then its graph is the set of all x, y such that, y equals f of x. In other words, this is the set of points of the form x, f of x, such that x is in the domain of the function. Okay, so the point is that when we talk about the graph of a function, this is a collection of points in which the first element in the order pair is whatever you want, as long as it's in the domain. But the moment that you pick the first element, the second one is already determined for you by whatever the formula is. You're not free to choose what to put here in the second element. Okay, you're free to choose what you write here. You're not free to choose what you write on the second coordinate because that's a dependent variable. Okay. So that's what the graph is. It's a relation, it's a set of order pairs. Now, of course, it has a picture. So typically what we do is we write a visualization of it. So, we have some sort of picture. This represents the function y equal f of x. And basically what we are saying here is that this point has the form x, f of x. Okay? Given whatever x is, then y is determined by that. Let me write this. Suppose that this is A, then this point has coordinates A, f of A. Okay? All right. So let's use this as an example. So let's practice the same thing. So this is quick. The same thing that we were doing before, evaluating function, but instead of me giving you a formula, I'm giving you its graph. Okay? And then I'm asking you the same type of question. Give me the value of -2, the value of 0, the value of 2. In other words, when x is -2, what is y? When x is 0, what is y? Okay? Those are the questions that we're asking. Before we were plugging into a formula because we have the formula. Now we don't have the formula, but we have this graph. And that's, that's perfectly fine. So let's see. F of -2. As you know, what do we do? You need to understand that we're saying here when x is -2, what is y? So you go to the picture. Here is x equals -2. Go up to the graph, then y is equal to 2. Okay? You read it from here. So this is equal to 2. Let's see, who can tell me what's f of 0? Yes?
2.
It's equal to 2, right? So when x is equal to 0, y is 2. So f of 0 is equal to 2. Good. And the next one was f of 2. What's f of 2? So x is 2, right here, that will be 6. Good. Are you okay reading the graph? Okay, perfect. So that's that one. Then let's see, let's do this one quickly. So f of 0 is going to be 1, 2, 3, so -3. Here f of 2 is going to be 1, and here f of 4 is going to be 5. Okay? So remember, that's what a graph of a function is, just a collection of all points in which once you give me the x, the y is already determined by the function. Okay? That's all it is. Okay, so let's do this one more time, and I'm going to use this to take advantage and introduce, we already talked about it last time, two special type of points the graph has. Okay? In particular, let's see, let's find these values. So let's find f of 0, let's find f of 1, and let's find f of 3. Let's see, who can tell me what's f of 0 equal to, according to this graph? So we're looking at This guy right here.
3.
So that's equal to 3. Good. What's f of 1?
0.
We're looking at this guy right here. What's f of 3? So we're looking at this guy right here. What is it? 0. So by the way, this also brings up another thing. To be a function, remember, every x has to have only one y. But nobody says that two different x's could have the same y. That's fine. Okay, like in this case, we have both 1 and 3, they both are related to the same number, namely 0. They have the same y. That's okay for a function. Okay? What can happen is that one input has more than one output. Okay? As long as you have only one output, they're good to go. All right. Now, why is this here? Well, because these points are special. For example, what's the point that we have here? What is this point in coordinates?
0, 3, 0.
0,3. Remember, this is the x, this is the y. Okay? 0,3. How do we call this point? Yes? The y-intercept. Remember, we talked about intercepts last time. Okay? So this is the point 0,3. And this guy is called the y-intercept because it's the point at which the graph crosses the y-axis. And what is this point? In coordinates? 1,0. What is this point in coordinates? 3,0. And what names do they receive? So these two guys, we call them the x-intercepts. Okay? So we talked about this last time. So these points are special. The y-intercept is a point on which the graph of the function crosses the y-axis. The x-intercept is a point on which the graph of the function crosses the x-axis. And right here you can see the recipe to find it. So this is y-intercept. These two guys are x-intercepts. So to find a y-intercept of a function, what is it that you do? You plug in 0, right? Because x must be 0. So you just evaluate the function as 0. Whatever number you get, that's a y value of the y-intercept. Okay. Now to find x-intercept is a little bit more complicated. It's not as easy as just plugging in, because to find an x-intercept, what happens is that the y value must be 0. So you have to find what x gives you y equals 0. Usually, how do you do this? To solve an equation, right? Because here you have then f of x, and you want that to equal 0, so you need to solve the equation, whatever f of x is. That's why we spend some time talking about equations in the first half, in the first unit, okay? Because with something as innocent as find the x-intercept, that's actually you have to solve an equation, okay? And depending on the type of function, it's the type of equation that you will encounter, quadratic or radical or rational. It depends on the function, okay? So let me say that. So note point 0,3 is called y-intercept of f, and the points 1,0 and 3,0 are called x-intercepts of f. Let me ask you a question. How many y-intercepts can a function have? Why? So otherwise it wouldn't be a function. Okay, relations can have many, as many as you want. But functions, they can only have one. However, how many x-intercepts can a function have? As many as you want, or maybe none. Understand this? There's no reason why it has to have an x-intercept. Like you could have a picture like this, right? So no x-intercept. Okay, so you don't have to have intercepts, but if you do x-intercept, you may have as many as you want or none. But y-intercept, maybe you don't even have y-intercept. That's okay. But if you have, there's only one. Okay, keep that in mind. All right, and then I think I wrote it last time, but let me just rewrite it. So remark to find the y-intercept of a function, what do? We make x equals 0. In other words, you find f of 0. This is really what you need to do to find the y-intercept. And then to find x-intercept, what do? What do we do to find the x-intercept of a function? So we make y equals 0. So in other words, we need to solve the equation f of x equals 0. Okay? So to find y-intercept, plug in 0. Whatever you get, that's your y-intercept. To find x-intercept, you have to solve this equation. Okay? All right. So let's see. Let's answer those questions. Let's find the intercept of this graph. Now, when you have a picture, this is easy. You just look at it. Right? That is really nothing to stress about. So x-intercept and y-intercept. So let's see. How many x-intercepts do you see? How many x-intercept? 3 x-intercept. 1, 2, 3. Yes? So they are -2, -1, +1. So the x-intercepts are -2, 0, -1, 0, 1, 0. And y-intercept? 1, this one right here. What is it? So it's 0, -2. Do you understand this? All right. Now, of course, once you have the picture, then what's the point? So the interesting thing is to do it from the equation point of view. So now I'm going to give you some functions, and I want you to tell me the intercepts. Okay? So find the intercepts, and when I write it like this, I mean both x and y intercept. Okay? And remember, this is important information to find anytime that you're going to graph something later on. You need to tell me the intercepts. Okay? So let's do this one. And let's do this one. So I'm going to do number 1, and then I'm going to let you try the others. Okay, so here we have 3 functions. Let's find the intercepts. Okay? All right, so solution. This is okay, so for the first one, we have the function f of x equals 2x squared plus 3x minus 5. So let's find the y-intercept because this is the easy one. So how do we find y-intercept? What do we need to do? Just plug in 0, right? So you find f of 0, which is -5. So the y-intercept is a point. So as a point, what is this? 0, -5. Good. All right. So x-intercept. How do we find it? So we need to make f of x equals to 0. In other words, we need to solve this quadratic equation. You're probably tired of solving this. You have to do a bunch of these on the exam. Okay? So let's do it, I guess, 3 more times. All right. So let's see. Can we factor this? So -10 and the sum is 3. So that's 5 and 2. So yes, we can factor this nicely. So let's do 2x and x. And then I'm going to do 5 and 1. I'm going to put my negative here. So 5 minus 2 is 3. So it would be 2x plus 5 and x minus 1 equals to 0. So we get x is -5/2 or 1. So what are the x-intercepts for this function? What are they? So -5/2, 0. So remember, these are points, right? So you have to determine the coordinates. And what's the other point? 1, 0. Good. Questions? Do you understand this? All right. So let's see. Go ahead and do number 2. So I'm gonna give you like 2 minutes to find the x and the y intercepts. What's the y-intercept? So 0, 5. Man, 5 is a number. It's not a point, right? So f of 0 equals 5. That's a point 0, 5. Good. And then for the x-intercept, you have to solve this equation. Can we factor this? Can we factor it? So how do we solve this? What do we need to do? Quadratic formula, right? Or complete the square, whatever is your favorite method. For example, I prefer to have negatives over here and positive a. So find the discriminant. That's going to be negative 3 squared minus 4 times 1 times negative 5. So that's 9 plus 20, which is 29. So the solutions here are negative b plus or minus square root of b over 2a. So that's 3 plus or minus square root of 29 over 2. And that's it. You cannot simplify this anymore. So the 2x intercepts, what are they? 3 plus square root of 29 over 2, 0. And the other one is 3 minus square root of 29 over 2, 0. Questions? Okay. And then the last one was f of x equals x squared plus 4. What's the y-intercept? 0, so 0, 4. Just plug in. Y-intercept is always easy. So you just plug in. How about x-intercept? So you need to solve this equation, right? So that would be x squared plus 4 equals 0, which means x squared equals negative 4. So what's going on here? There's no real solution, right? Because solutions here are imaginary, but we're talking about x-intercept, so we're looking for actual points on the graph. So are we crossing the x-axis? No, we're not crossing the x-axis. There's no real number x that you can put here that will satisfy this equation. You understand this? We don't have complex numbers in the picture. So, no real solution. So, no x-intercept. That's okay. It's okay not to have an x-intercept. All right. Questions about finding intercepts of a function? Okay, good. So what we're going to be doing next time is we're going to analyze graph a little bit more carefully. And we're going to start, when you have a function, the first thing that you need to know is what's the domain of a function. Okay? From the picture, it's an easy question. Of course, the question is if I give you a formula, you need to be able to tell me the domain. Okay? Talk about this. Then after that, we will start looking at graph, transformations, and all of that business. Okay? All right. Happy 4th of July. Enjoy. And see you on Tuesday.